me continue that problem. I had forgotten to write the meaning, and I think the most important meaning of this epidemic here in New York City between 1918 and 1919 was that maximum right there. There's more of this in WebAssign, this problem, meaning the maximum weekly excess death rate was 90 deaths per 100,000 people, which occurred between October and November of 1918. So that is what I would expect for a meaning. I hadn't written that before, so I wanted to pause and start this new video. Continuing 4.2. Let's look at number 3. Number 3 says, find the absolute extrema of the function on the closed interval. So real important here is absolute extrema. And notice that all of these are on closed intervals. So this first one, I'm looking at this function, f of x equals 2x to the third minus 3x squared minus 12x plus 1. It's a polynomial. Domain is all real numbers. Now they want you to just look at it between negative 2 and 3. What you need to do is consider the critical numbers of this, and here are the steps over here on the worksheet. To find absolute maximum and minimum values of a continuous function f on a closed interval from closed a to b. Step 1, find the critical numbers on the open interval. Step 2, find the values of f at the critical numbers and at the endpoints. Step 3, the largest value from step 2 is the absolute maximum, and the smallest value is the absolute minimum. So we're going to do these steps. So I'm going to find where the critical values. Now the critical numbers, that was above. It says, what does it say? Definition. A critical number of a function f is the number c in the domain such that f prime of c equals 0, f prime of c is undefined. So we're going to take the derivative of this function and find out where it's 0 and or undefined. So if I take the derivative of this, you get 6x squared minus 6x, excuse me, minus 12. Now we want to know where that is 0 or undefined. It is defined everywhere in the domain, all real numbers, and on this interval. So if I take this, set it equal to 0, factor out a 6, factor those, set those equal to 0, I get x equal 2 and x equal negative 1. And again, you can always pause this and work this out. Now, once you get these critical values, all you have to do is find f of the critical values and f of the endpoints. That's what I always try to remember. If I'm looking for absolute extrema, we'll have another section on the local extrema. But this is just the absolute extrema. You're going to look at your critical values, which were at 2 and negative 1, and the endpoints are negative 2 and 3. And you're going to find the function value, not the derivative, the function value at 2, negative 1, negative 2, and 3 at the endpoints as well. So those are my critical values. These are my endpoints. I plug 2 into original function, so plug that in, and you get negative 19. This one I plugged in, I got 8. This one I plugged in negative 2, I got negative 3, and f of 3 is negative 8. Now, I look at the largest number here, which is 8, so that means that's the absolute max is 8. And this right here is negative 19, so your absolute min is negative 19. Now, I would like to show you on the calculator, so here we go. I've already put this in here. I've put several in here for later, and I can just turn these off and on by tapping on the equals. So those two are off and that one's on. So I'm looking at this polynomial here, and I'm just doing a zoom. Oops, let me do a zoom 6. So zoom standard, plus or minus 10, plus or minus 10. And we're supposed to be looking at this from negative 2 to 3. Now let me show you a new feature. If I go to the window and tap negative 2, enter, and 3, so that is the interval over which I'm looking at this function. And if you hit zoom, and this one I don't believe we've done in class yet, but there's a zoom fit. Now zoom fit will fit that x min and x max that you just put in. So I'm going to hit enter, and notice that it is giving -2 to 3, and it's giving us that polynomial on that interval very nicely. Zoom fit from that x-min and x-max. And notice that your absolute max is here at -1, and that height is 8. And this right here, min, is at 2, and it is -19. And you can check those by taking your second trace, and you can look, if you're looking for a maximum, you can go to maximum. I don't know if we've done this in class. Hit enter. And if I want this maximum over here, you need to scroll. It says what left bound? Right here it's saying what left bound. And if I hit enter, I'm kind of going to the left of that peak. I know it's kind of hard to see, but I've gone to the other side. So that's a left bound. It says you want that to be your left bound. I'm going to hit enter. And then it asks for a right bound. So I'm going to go up over this. All right, just over the hill. So now I'm going to hit enter there. So I've got a left bound and a right bound, which is saying that the peak is in between those bounds. And then it says, you want to guess? I never guess. I just hit enter. And it will give me this ordered pair. It's calculating that peak, which is what -1,8. And that's what we had over here, -1,8. And that's the absolute max. Let me show you the min. So this minimum is right here. So I'm going to go second, trace, and do you see the minimum right there, number 3? And I'm going to go, it's asking left bound. So I have to go scroll. Here we go. Scrolling over, well, where did it go? Let's see, my x is at -0. All right, so here I go. This is hard to do and tape at the same time. So I go somewhere near it. So right there. So I'm at the left of that minimum. Enter. And then I'm going to go down below and come back up and hit enter. So I've created a left bound and a right bound, which is indicating to the calculator where that minimum is. And then if I hit, I don't want to guess, so I'm going to hit enter. And it gives me, well, mine is giving me 1.999999, which shows that it's not exact. Although if I round that, that's 2. As a matter of fact, the answer is the 2, -19, where that's the absolute minimum. But the program that was programmed into this calculator uses that min and that max, or that left bound and that right bound to calculate this value. So if you do this at home, you may get something a little bit different here. Maybe you'll get 2.000001, or maybe you'll get exactly 2, -19. It all depends on that left bound and that right bound that you put in there. All right, we'll be back for the next question.